Hello, this is Ahmed Atif holding ID number 1093736. Today we are going to explain what we did in Lab 2 for the course Data Communication and Networks. So this lab consists of multiple parts. I will explain the first two parts and my colleague will explain the rest of the lab. So let's begin by the first part of this lab. We were asked to find the code word using two methods. The first one was the CRC or the binary. The second method is which is a new method, which is polynomial division. Okay, and of course we saw the video here to know how to do a polynomial division. So let's begin. Here is the binary division, CRC. Okay, the data word is given using a polynomial. Okay, and the divisor is, as we can see here, x power 6 plus x power 3 plus x power 1. First, we add redundant zeros. Now, how to know how many zeros we added? We have to check the divisor. The divisor has 7 bits or 7 digits. We have to add 6 zeros or n minus 1 zeros to the right of the data word, and then begin XORing until we reach to the remainder. We found that the remainder is 101010 in our case, so this remainder will be added to the data word to form the code word. Now, using polynomial division, it is similar way, but instead of XORing, we are subtracting. So if you can see here, we first write the divisor, and then we wrote the highest, which is 6 plus the highest power of the divisor, and we added to it to the data word. As we can see, x power 9 plus x power 6 give us x power 15, x power 9 plus x power 8 plus x power 6 give us x power 14, and so on. After we finished the polynomial division, we found that the result is x power 5 plus x power 3 plus x, which is matching the binary result. So as we can see here, 101010, and of course the code word is formed by the data word plus the results of this one, or the remainder. For the second part, which is about the stop and wait protocol, okay, we are going to send or transmit 5 blocks or frames, and in our case the third block will be lost and the fourth acknowledgement also will be lost. So as we can see here, the sender start to send he want to send these blocks or frame 010101. He will send block 0, and the receiver will receive block 0, update RN, and then send acknowledgement 1, and so on. Arrival, update SN, and the new request for send block 1. Block 1 is sent, and then the acknowledgement, which is RN updated, and then acknowledgement of block 0 is sent to the sender, and then the third block will be sent by the sender. Now, as we can see here, there is a lost. So after the sender actually start the timer, and if the time, and as we can see here, the timer started, but no acknowledgement is received here. The timer is started, but from the request the timer is started and no acknowledgement is received by the sender. Therefore, timeout, and he will resend block 0 again. Block 0 is sent, acknowledgement 1 is sent by the receiver, block 1 is sent but here, look, acknowledgement, the fourth acknowledgement or the acknowledgement for this block was lost. So what will happen is, similarly, from the start time there, from the request, there is a time that has been started from the sender side. The sender didn't receive the acknowledgement, therefore the time's out, and then block 1 will be resent again. Now here, the receiver already received block 1, as we can see. So when the sender resent block 1, the receiver will discard it to so that there is no duplicate occurs, and then acknowledgement 0, and then the last the fifth block or frame is sent and the acknowledgement is received, and of course if there is the rest of the frame will be sent. Okay, now in the stop and wait, very important to know that the window size of the sender is 1 and the window size of the receiver is 1. That's it for part 1 and part 2. Thank you all.
Hello. For the second part of today's lab, we're going to install Wireshark, which is a capture and analyze local INCP data. It's a packet tracer actually. So first step, we typed ipconfig in my own PC. As you can see in the wireless LAN adapter Wi-Fi, you can see the IPv4 address 192.168.107. This is the IP address that I will use during the lab today. And I got my phone's IP address as well from the Wi-Fi settings, which is 192.168.68.104. So my first step was to ping my phone from the laptop, and I pinged it, and I got a response, and I captured it during with Wireshark. I also traced RT, which is to check if there is a connection to my own phone, and it worked. And I pasted then a Wireshark picture of my of the ping connection to my phone. We can see there's a source, which is my own PC, and destination. So for part 3, we're gonna ping our default gateway server, and then we can check what packets can Wireshark capture. First, we get our default gateway, which is this IP address from ipconfig/all, and then we can see here we cleared the ARP, and then we ping this default gateway server, and we captured it with Wireshark. We can see that the first source is our IP, our own PC, sending a packet to broadcast, which is each device. Why do we do that? We can see here we answered that question because we need to configure to resolve the IP to a MAC address. We're sending the packet to each device on the server to know which devices are connected. And then we can see here the gateway MAC address. It's this one. The first 3 digits will be the NIC vendor ID, and the last 3 bytes of the MAC address for A41D314, they're gonna be the NIC serial number of the source. And this is the end of our part 3. So for the fourth part of our lab, we are going to use Wireshark to capture and analyze Ethernet frames. So we will basically ping our default gateway and capture it using Wireshark, and you can see it right here. We captured it. We can see that our source to destination is our default gateway. We can see that our first ping was a echo ping request, and you can see that the source is our default gateway MAC address, which is basically our router. That's our source, and our destination is our MAC address router. Our source is of course our PC. We can see what type of frame is displayed. We can see it here, type IPv4. And next we can see the source IP address, destination IP address. What do the last 2 highlight octets spell? We can see here in our Wireshark that the last 2 octets are high, HI. As we said, our device MAC address displayed as our destination address, which is our own PC is our destination address. In the reply, we can see it here. In the reply, our destination is our own PC address. Next, we are gonna ping the www.cisco.com and capture it with Wireshark. We can see here we captured it. The source IP address is our IP address, and the destination IP address is the Cisco IP address. However, we can see there is a problem, which is we can see here the source is our IP address, PC IP address, but our destination IP address is the default gateway, our router's MAC address. Why is that so? We can see here the IP changed because our target is an external host. but the packet it will still leave through our router's MAC address using hop-to-hop delivery. So it should have the same MAC address. It won't change. For the last step of part 4, we're not going to use a team member MAC address. We're just going to use the ping above. We can see, does the source MAC address match your PC? Of course, yes, it will match my source MAC address, which is my PC interface. You can see it right here. But the Wireshark will not match Cisco's MAC address. It will match my own gateway's MAC address. And how does it obtain it? Using the ARP protocol, using both ARP request and ARP reply. In step 5, part 5, we need to capture and analyze remote ICMP data in Wireshark. First, we pinged our Yahoo, Cisco, and Google.com. And you can see here we captured it using Wireshark. We can see here that the destination IP address, for example, here it was Google, it was Yahoo, here it was Yahoo, and 23.208.213.8 is for Cisco, and the last one is for Google.com. But for all of them, we can see that the MAC address, the source MAC address is our IP, our MAC address, of course, but the destination MAC address is 98, the BA5F41D314. What's this now? This is our router MAC address. Why? Because packets usually go from MAC addresses. They use hop-to-hop delivery, so they go to the router MAC address. So this is the end of our lab. Thank you for listening.